This is Evone, the mechanical small lumen ventilator. Before use, Evone needs to be assembled with the following accessories: a single-use cartridge with pressure lumen, a reusable airway adapter for mainstream capnometry, an HME filter, the Evone breathing tube of 1.5 meters, and tri-tube. After assembly, Evone can be switched on, and after an automatically executed self-check, a startup check can be performed. Patient data need to be entered for default ventilation settings, and the patient needs to be intubated with tri-tube, a small lumen endotracheal tube with an outer diameter of only 4.4 millimeters. Tri-tube is an ultra-thin 3-lumen ventilation tube with a ventilation lumen with Murphy eye, a pressure lumen for continuous intratracheal pressure monitoring, and a cuff lumen to inflate the cuff. The ventilation lumen and pressure lumen of tri-tube are connected to the breathing tubing and pressure lumen of Evone, respectively. Ventilation is started by tapping the Start button on the screen. Graphs displayed show end tidal CO2, intratracheal pressure, and inspiratory volume. Please note the typical pressure curves with linear increases and decreases in intratracheal pressures. The typical linear increases and decreases in intratracheal pressures are caused by the unique ventilation technology inside the cartridge, which is called FCV. The cartridge has 3 points: a pressure lumen port for intratracheal pressure monitoring, an FCV inlet port, and a jet inlet port. Let's first focus on the FCV inlet port. Inspiratory flow is constant until a set peak pressure is reached. During inspiration, the gas outlet port is closed. When the preset peak pressure is reached, the gas outlet port opens, creating gas flow through the nozzle. This creates a high-velocity stream and a local pressure drop, resulting in entrainment of gas from the patient outlet port, generating an active expiration. During this ventilation in FCV mode, a sealed-off trachea and thus inflated cuff is required. The physician can appreciate the typical linear increase and decrease in intratracheal pressure, which are displayed real-time on the screen. At the bottom of the screen, the adjustable parameters are displayed. Measured parameters are shown at the right-hand side. Parameters can be set by tapping the screen. Setting inspiration flow, or IE ratio, affects minute volume and breathing frequency. A higher flow results in a higher minute volume and frequency, while reducing the IE ratio by prolonging the expiration phase reduces minute volume and breathing frequency. Adjusting the peak pressure or end expiratory pressure, EEP, affects inspiratory tidal volume and breathing frequency. A higher driving pressure, by increasing the peak pressure or by decreasing the EEP, leads to an increased inspiratory tidal volume and a lower frequency. Please note that minute volume, tidal volume, and breathing frequency cannot be set directly. Evone has several audible and visual high, medium, and low priority alarms indicating physiologic deviations or technical problems. Evone indicates when a physician's action is required. Evone has a jet mode to merge a patient from mechanical ventilation to spontaneous breathing using traditional subglottic high-frequency jet ventilation. The jet inlet port of the Evone cartridge provides jet ventilation with 60 to 150 breaths per minute. An open airway is required, therefore the cuff needs to be deflated before starting the weaning mode. This mode is used for breathing support, which is not triggered by the patient, to facilitate a comfortable transition from mechanical ventilation to spontaneous breathing. Thank you for getting acquainted with Evone, the mechanical small lumen ventilator.